So the silence convinces me that we're going to talk about the function version of it again. On my computer, it was called password 2. Here's the version that the homework was going to be based upon, I would assume. It asks for a password up at the top, and then it goes into a for loop. For every character in the password, it checks to see if it's a space. If it's a space, it increments the spaces by 1. Checks to see if it's upper. If it's an uppercase, it increments the uppers counter by 1. If it's not an alnum, alphanumeric, it increments the specials by 1. Then it printed some data out, which is not really strictly necessary for a user to see, but useful for us to check our program. And then we had a series of if statements. If space is greater than 0, whatever, you know. If uppers is equal to 0, it's bad. If specials is equal to 0, it's bad. If the length of the password is too short, it's bad. So that's the way the program was originally written, with a for loop that processed all these counters. Then we rewrote it to look like this. We wrote a couple of functions, one called count spaces, one called count uppers, and then instead of a for loop, right in the middle of our program, underneath the input statement for getting the password, and then the place where we printed them out, the place where we calculated these spaces looked just like that. It was a call to our function. And the place where we counted our uppers looked just like that, to a call to our count uppers function. And then the for loop was tucked away inside each of these functions. So this one is slightly more efficient because we only have one for loop. And here we would call for loop a separate for loop for every type of character we were counting, uppercase, lowercase, digits, specials, spaces, that kind of thing. But sometimes clarity of code is more important than absolute efficiency. Computers are so fast nowadays that it's okay if something processes like 0.05 milliseconds longer, you know, if it makes for clearer code. And so when I demoed this, I had some comments that this looked like a cleaner solution. You know, counting the number of spaces, counting the number of uppers by calling functions. So this code and this code are equivalent in the main logic of the program, with the complexity of doing these two things tucked up somewhere else. They could even be put in another file that you access with an import statement. So get into Lucidchart. I can reset passwords, but it's slightly tedious. Just let me know if you need me to do that. Or I can look up your email address if you don't remember which one you used to sign it up with. Alright, this text is going to be too small for you to read most likely. But you can pop up the password program on your own screen if you want it. All we're going to do is change it directly into flowcharting. So let's make a box with our program information. Your name, the date, password checker flowchart. Stuff like that. And just tuck that to the side somewhere. I'm going to push that over on the... All right. Remember, you can zoom in and zoom out with the control key and the mouse wheel. All right, what was the very first thing that our that our program did? And as a secondary question, what's the very first thing that has to be in a flowchart? My mouse is kind of hovering over the answer.
The start.
Yeah, we're going to put a start. Then what was the next thing it did? The first thing it did, actually. In order to check the password, we have to... Come on, guys.
Ask the question.
Right, we have to ask the question. I'm going to have to start calling out names. You don't want that. Alrighty, so input password. That's enough. We don't need to get into nitty-gritty details of the syntax because it varies language by language. Alright, what symbol did we use for a while loop? The reason I'm asking is we're going to use the same symbol for a for loop.
Diamond.
Somebody on this side of the class.
Diamond.
Yeah, the diamond. And strictly speaking, in classical flowcharting, you don't put the word for and while in these, but absolutely everybody who's a programmer knows what a for loop is and a while loop, so we're going to go ahead and put that syntax in here. For CH in password. And if you feel like you need to embed a space, a return inside your shape in order to get the text to look better, Control Enter will do it. All right, every diamond has two arrows leaving it. One's a yes side and one's a no side. The no side is what happens when, if the if statement is false, it goes that way, or if the while statement is done, it goes that way, or if the for is done, it goes that way. But we care most about what it's doing when it's active. So the first thing we did is we initialized some counters. And honestly, that should have been done before the for loop. My mistake. We're going to just draw a new box with some initialization statements. And since these are all just setting the counters to 0, I don't mind them all going into the same box. If it's a series of statements that don't perform essentially the same function, because in some languages you could do all of those initializations in a single line of code. So anyways, if you're doing input and then you're doing calculation and then you're doing another calculation, no, those don't all go in a process block. But when it just looked like this, spaces is equal to 0, Control Enter, specials is equal to 0. Oh, Shift Enter also works. And then uppers is equal to 0. Now, since I left this out, I'm going to take the lazy way out and just pull that for counter down and push this on top of it. There we go. Now we have some if statements. If the character is a space, if the character is uppercase, if the character is not alphanumeric. Now we could write these function names or we can just write a text description of it. I'm just going to write the text description of it. So if CH is a space, then we need to jut over here and increment the number of spaces. When we change the value of something, that's math. And what does math go in?
Process.
Goes in a process block, rectangle. So spaces plus equals 1.
Plus equal 1.
Yeah, sorry you can't see that. Let me zip that over. And do you have to have a circle after every if for the things to join up? I have been putting them there just to make things clearer. They're not strictly necessary as long as you can make clear what the program is doing. I'm going to play with not doing it, and then if I decide that they made things more confusing, I'll have to revise it. I think it made it more confusing. You okay with that, or do we need to put a circle there where they join back?
Probably circle.
I'm going to put a circle there. All right. Itty bitty circle. Take the A out. Don't need no A in it. Draw a line to it. That line should say no, because that's what happens if the CH is not a space. And then that guy needs to come back to it. And these if statements all look very similar if we look. If character is a space, increment counter. If character is an uppercase, increment a counter. If not, character is alnum, increment a counter. That kind of implies that we could copy these things. I'll show you what I mean. Just highlight those guys, those three blocks and the lines that connect them. Control C to copy. Click off so that everything is deselected. You don't want anything selected. And then Control V as in vehicle to paste. And then just drag that down. And we only have a little bit of stuff to change. The second if statement is not if CH is a space. It's if CH is uppercase. If that's true, then uppers plus equals 1. Right now I have a dead end, so that no needs to extend down to that next diamond. Then just do it again with the third if statement. It's already in your buffer. You can just hit Control V again, paste it again. I suppose right click works too. Maybe not. Deselect everything by clicking on the white background. Control V to paste it. Drag your new blocks down there. And this one needs to say if CH is not alnum. Or we could write out the words alpha numeric. Or we could say if not letter or digit. And if that's true, then increment the number of spaces by 1. Excuse me, I'm not incrementing spaces there. What am I incrementing if it's not an alphanumeric? Yeah, specials. Alrighty, that is all that our code checked, along with length. But length is done not with an if statement. Like that. It's just checked down below when we validate whether these values are enough or not for it to be an acceptable password. Now, if this was a while loop, we would need a line coming back up to it. If it was an if, we don't. For loops are effectively while loops, just with a special syntax. So I'm going to draw a line back up to that for. Then I'm going to walk around and see how we are all doing. While we're drawing, we may as well do a save as. Just file, or excuse me, file save. Call it password checker. Why? That way if your browser quits or something, you're sure that at least it's saved up to this point. Alrighty, when I do a program, a flowchart, I like to make all the lines go straight down. When I possibly can. However, that means if I did that, then I'm going to stretch that way down there like that. I could just kind of jut it off to the side, make my no go off to the side. That'd be a little bit easier perhaps. The reason I like to line them up like that is that matches the indentation level. You know, as soon as you hit the for statement, you start indenting. As soon as you hit the if statement, you indent again. The only thing where that fails is when you have an else, but we don't have an else in here. I guess I'm going to go ahead and go with that. If you don't want to drag a huge line straight down like that, that's okay. You could grab that little word no, I believe, and pull it back up so that it's closer to the diamond if you care. Alrighty. We had some print statements in our code, but that's not really essential to the logic. That's just really kind of debug information. If you type a new password into Google, it doesn't tell you the number of spaces and the number of specials and the number of uppers. So we're going to leave that off, and we're going to go straight down to the validation code that checks to see if these counters are adequate for it to be a good password. I don't know if any of y'all ever read XKCD, the comic, online. It's incredibly nerdy. But there's one about password strength. So, suppose you're logging into something and it's insisting on a certain number of uppercases and lower cases and special symbols. So what you do is you try to make a word and then you make some of them symbols and stuff like that. You probably have all done things like that, or maybe not. You know, password with an O and a 0 instead of an O or whatever. So that gives us a quote a certain level of entropy. And he goes through some calculations. Was it trombone? Was it troubadour? Which one of the zeros was a O? Excuse me, vice versa. Oh, and there was a symbol in there, difficult to remember. On the other hand, if you just choose 4 random words, correct horse battery staple, then that is a far more random password as far as a hacking program, a guessing program goes. The longer your password is, the far more difficult it is to crack. And then you can memorize that. It's very difficult to guess, and it's very easy to remember. If you can just remember the correct horse battery staple. That's a battery staple. Correct! You've already memorized it. Okay. Through 20 years of effort, we've successfully trained everyone to use passwords that are hard to remember and easy for computers to guess. That was okay. That's kind of a, most of his comics are funnier rather than informative. Funny is a relative term, though. Let's go back and do our if statements now. The first one is we had to set our flag, is valid. That's kind of a mathy thing. We're going to stick it in a process block. Is valid equals true. I'm going to make it a capital T, just like Python, although that's not necessary in a flowchart or pseudocode. And if we had taken this from pseudocode, we would probably use the word set in front of this. But we're kind of like Bob Ross, the painter here. And, you know, we just go with what makes a pretty picture, and I don't think the set is necessary here. Okay, so is valid equals true. Now we have some if statements. If spaces is greater than 0, we set that flag to false, and we print an error message. So an if is a diamond. If spaces is equal to if spaces is greater than 0, we're going to change that flag to make it false. It's no longer valid. And we're going to print an error message. In a different environment that wasn't kind of real-time programming like this, not that this is really real-time, but like if this was running on a web server, you wouldn't be printing messages out because the web server doesn't care. Instead, you'd be building a string that you'd pass back across the internet, and then the browser would display that error message. But anyways, so here we go. We're going to print or display whatever our favorite keyword is. I'm just going to go with print. Print must have, must not have any spaces. And then loop that back to a circle. And you can kind of guess where this is going. We're going to do the same cut and paste trick. Why does that work? Because we're doing kind of repetitive tasks here. It's not the same thing each time, but it's a similar operation. Alrighty, so now again we can grab these four shapes copy them, scroll down a bit. We're hitting the end of the page, but that's okay. When we drag this down, it'll add on a page. If we wanted to, we could fit all this on one page by putting a kind of a circle at the bottom with a big A, and then a circle at the top of the next column with an A, and you would know that, A goes to A, but we don't need to do that. All right, the next if was if uppers equals 0. So I'm going to change this if to say if uppers equals 0. And I'm using two equal signs because that's fairly universal in programming languages to distinguish assignments, which is when you set a value, to comparisons. Again, this one's fine. We're just setting a flag is valid equals false, but the error message needs to change. Must have at least one uppercase. I'm going to temporarily zoom out and see how this is shaping up. It's okay. All right, all of that should still be in my keyboard buffer, so I can just hit Control V again, paste it. This will be the last if statement. No, because we also checked the length. There's going to be one more after this. So you know what? I'm just going to paste it one more time. I pasted 2 copies of it, and I need to modify them one at a time. The first check was spaces. The second one was uppers. The third one is specials. If specials equals 0, invalid equals false, print must have punctuation, must have a special character. Must have at least one punctuation. And the last one was if length. If length is less than or equal to 7, we're going to print an error message. We never even show how to calculate the length of the password, so I'm just going to type if length of password is less than 8. Why not make it that instead of less than equal to 7? Is valid equals false, and our error messages must be at least 8 characters long. And then lastly, we just printed the value of is valid. Kind of cheesy. We should have put an if statement in there that said, if the password is valid, print true. Else, print bad password. I'm going to go with that idea, even though that's not what our code did. So here's our final check. If is valid, that's really enough. You don't have to say equals equals true, because just saying if is valid is enough, because that compares it to true. So if it's a good password, I need to change this a little bit. We're going to print password is good. I'm going to delete that little line going to the no, because we need another line that kind of serves as our else. And so I'm going to actually make that go off to the side. It's just easier to spot that way. So since that's a print statement, it needs to be in a tilted rectangle, quadrilateral, print password not good. That's almost extraneous. We've already printed an error message. Then these guys can meet back at the circle, and we're done. We're going to go to a stop. Then just make sure everything has lines, so we don't have any dead ends or little breaks in the lines. It's not letting me select these lines and delete them now. And maybe eventually you can. If you can't get it perfect, that's okay. Alrighty. And then finally, go down to a stop. If you have an if block and there is something that you do on each way, that means that there's an else involved. And you can make that no say else, or you can make it say no slash else. Something like that. I do that just because a lot of people wish that there was an else symbol. There's an if symbol. Why is there not an else symbol? It's just because it's implied. So we're going to list it there. So go ahead and make a new one. This is going to be, oh, that's odd. I'm just going to click close and then do new document that way. I know I could work faster with add-ons. Stop it. Plus document. Okay, so again, it starts with a start terminator. And go ahead and switch to this one, guys. This one's not going to be as long as Harry. It's going to be kind of different. Let's input the password. We need our functions. We need our space counter and our upper counter. So, to define a function, you also use a terminator, except instead of using the word start, you put DEF. Let's do count spaces. And you pass a string in, so I'm putting a parentheses S there, like that. So we're going to have a for loop right here inside of that function for ch in s. And again, I forgot to initialize my counter, but I'm just going to call my counter x. So put a rectangle there that says x is equal to 0 and drag that there. And we're looking for spaces, so our decision says if ch is space, we're going to increment x. X plus equals 1. Let's make our yes lines and our yes path and our no path meet in a circle. And then we're just going to loop that back to the for loop like that. And then we're going to, at the no side of the for loop, do a return. We're going to return x. That's our counter of how many spaces we found. So you see the difference between our, quote, main code, start and stop, and in this case, our function, we begin with the def keyword, and we return a value. Perhaps. Not all functions return values. Alrighty, we're only going to do one more of these. We're not going to list as many as we did on the other ones, but just copy that entire function. And then deselect and paste. And we could put it underneath, or we could put it off to the side, whatever. This one isn't called count spaces, it's called count uppers. So we need to change that word. I'm going to make that a different color to make it really obvious that we changed that. If I can see how. You don't need to change that. And then instead of if ch is space, if ch is uppercase. So change that as well. And we're done. And by the way, the only place that you should consider putting that else keyword under the no is if you meet two conditions. One, it's not a for or a while. And two, if there actually is some code on the no branch. Here there is no code. It's just dropping straight down. Well, if this was an if statement, I mean, you know. All right, we need to use these functions, which is going to require me to scroll back over, which I'm not too happy about. So I'm going to move this one over so that we can get it back on the screen a lot. You don't need to do that. All right, so let's find out how many spaces there are. It sure is a lot easier now because we have a function. When we make a function call, we use a rectangle, but we use a rectangle with bars. That textbook that I was copying from shows horizontal bars. We're going to use vertical bars because that's what this flowchart program gives us. So spaces is equal to count underscore spaces, parentheses, password. And then just draw another one of those underneath it that says uppers is equal to count uppers. Uppers is equal to count uppers password. All right, at this point, the rest of the program would be the same as our other one was, where we set an is valid flag, is valid equals true, and then I'm just going to kind of end it there. I don't know what kind of symbol I'm going to use to mean, and then I don't know, etc., etc., etc. How about that? And this is the place where we have that code that says if spaces is greater than 0, print an error. I guess we could do something better, something more informative than etc., 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 like validate password, but I'm just going to leave it like that. That's the same as the other flowchart. We could just go and copy and paste that code. Our other flowchart checked one more thing. So along with count uppers and count spaces, what else did we do?
Point. And
Specials. You could make a specials pretty easy just by copying this function again and pasting it. If you're caught up on the other one, go ahead and do that. Do define count underscore specials and then change your if statement accordingly. One last thing that I like to do in this class in 1113 is I will go ahead and color code my functions. That makes it blatantly obvious what I am calling. You use the little paint bucket symbol. You don't have to do that. Like that. All right, I'm ashamed of that, etc., 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 but I don't feel like making this more complex. You see what's different about this one? We don't have a great big for loop right here. Instead, we just have some function calls. This complexity is hidden inside the functions. Those functions can be in another file, which you bring in with an import statement, like we do import turtle. So you can make your code much cleaner by embedding the complexity in a function. All right, that's enough for that one. You can go ahead and switch back to the first one if you need it to give some tidiness. And also we need a Dropbox for these. So I'm going to do a save and call this one password with functions. And then when I download them, they'll have more interesting